Therefore, the first law is called Charles' law. Charles' law, this law explains the relationship between the volume and the temperature at constant pressure. Very important. Charles' law talks about the volume and the temperature, while the pressure is held constant. But remember, there is also a fixed mass, means the mass of the gas is also held constant. Not only held constant, it is fixed. Means there is no variation of mass at constant pressure, while the volume and temperature are varying. This is called Charles' law. Now, Charles' law talks about the relationship between the volume and the temperature at constant pressure of a fixed mass of a gas. How does it happen? How does it happen? Very simple. How does it happen? This is very simple. Now we're talking about volume and temperature. Now, Charles' law of a gas states that the volume of a fixed mass of a gas is directly proportional to the absolute temperature. Means volume is directly proportional to the absolute temperature. At constant pressure. At constant pressure. Therefore, we say volume is directly proportional to the temperature at constant pressure. Now, means pressure is held constant while temperature and volume are varying. But the variation between volume and temperature is directly. So they are directly proportional to each other. Means once you are increasing the volume, also you are increasing the temperature. Once you are increasing the temperature, you are increasing the volume. So temperature and the volume are varying at constant pressure. That is Charles' law. Therefore, mathematically, removing the proportionality constant here, V is equal now to KT. This K is proportionality constant. And this proportionality constant comes from the what we call it pressure. Means here K is pressure. This is proportionality constant. Now this is constant. Now at different conditions, now we have said volume is that proportional to the temperature. Removing the proportionality constant, volume now is equal to KT. But this constant is called pressure. Because according to the law, pressure is very constant. Therefore, V is equal now to KT. Then, at different conditions, for the first condition, V1 is equal now to KT1. This is the first condition. This is the first condition. What if now the volume is changed? Means it's turned to V2 will be equal now to KT2. This is the second condition. Means you have changed the volume. If now you have changed the volume, also the temperature. This is due to the change in temperature. Now the first volume of this one at this temperature, and the second volume of this one at this temperature. Now this is the first equation, and this is the second equation. Now, if now you are looking for the K, now here K is equal now to V1 over T1. The same applies to here. K now is equal now to V2 over T2. Simply because this proportionality constant are equal. Therefore, V1 over T1 is equal now to V2 over T2. So this is the formula that can be used to determine. Or in the other case, alternatively, Now you are having V1 is equal to KT1 and V2 is equal now to KT2. Once you find the ratio of these two equations means V1 and this one. Therefore, V1 over V2 is equal now to T1 over T2 because this will cancel out. So you may use this formula to determine what is missing, or you may use this formula to determine what is missing. But all in all, at constant pressure. So remember one thing, the pressure is held constant while volume and temperature are varying. Now the pressure is held constant while volume and temperature are varying. And that is what now we obtain this equation. Now this equation is so important for us to use it. But the temperature that we use is absolute temperature. Once it is given in terms of degrees Celsius, you add 273 to become Kelvin. Example now, you are having 27 degrees Celsius. So now you need to use it, you must add with 27 plus 273 to obtain Kelvin. So very important here, when solving equations, you make sure that this is converted. Now this is 300 Kelvin. So this is the one that we use and not degrees Celsius, because we're talking about absolute temperature. So whenever now you've been given in terms of degrees Celsius, you have to convert them into Kelvin. But once you've been given in terms of Kelvin and you need degrees Celsius, means you take that 300 minus 273 to obtain what we call it degrees Celsius. Sometimes you may be taught to convert degrees Celsius to Kelvin. Add up with 273. Or sometimes you may be given Kelvin to convert into degrees Celsius. Now you subtract 273. So this is all about Charles' law. Now let us say an example about Charles' law. We have this example about Charles' law. A 0.20 meter cubic container with a movable piston holds nitrogen gas at a temperature of 20 degrees Celsius. What will it be, the volume of a gas, if the temperature is increased to this one? Now the volume of the volume V1 now was equal now to 0.20 meter cubic. It was this volume at T1 at a temperature of 20 degrees Celsius. And the question is, what will be the volume? What will be the second volume when the temperature was changed to 50 degrees Celsius? This is at constant pressure. So because here now we're talking about the volume and temperature. Once you find there is a variation of volume and temperature, that is all about Charles' law. But once you find there is a variation of volume and pressure, that is another law. But according to Charles, as we have said, it is all about relationship between volume and temperature at constant pressure of a fixed mass of gases. Therefore, according to Charles' law, from Charles' law, we say V1 over V2 is equal now to T1 over T2. But remember, substituting what we've been given, V1 is 0.2 meter cubic over V2 is absent, is what we are looking for. Is equal now to T1. T1, we are having 20 degrees Celsius. but you have to add this 273 so as it may become Kelvin. This is 293 Kelvin. And T2 now is equal now to 50 degrees Celsius. Therefore, we have to add this 273 to become Kelvin. That is 3, now this is 12, and then this is 3. Now this is Kelvin. Therefore, this is what you are supposed to use, and not this one. Therefore, T1 is 293 over T2, 323. Therefore, you are looking for the value of V2, your cross multiplication. It is where now you have 293, that is V2, is equal now to 0.2 times 323. Therefore, you divide by 293, you divide it by 293. Therefore, this cancels. Now, you remain with this, which is meter cubic. And therefore, the second volume will be equal now to 0.22. This is meter cubic. Now, the new volume, the volume that is V2 will be equal now to 0.22 meter cubic at 50 degrees Celsius. So when the temperature was changed to 50 degrees Celsius, the volume was recorded to be 0.22. As you can observe, the first one was 0.2. Now the second one, it is 0.22. Means once the temperature is increased, also the volume is increased. So because we have said from Charles' law, volume that proportion to the temperature at constant pressure. As you can see, once the temperature was increased, also the volume was increased. So this is how. Now if now you find there is a variation of volume and temperature, that is Charles' law. Another one is here. Our gas occupies a volume of this one. V1 is equal now to 20 centimeter cubic. This is V1. And this V1 was recorded as T1 at a temperature of 27 degrees Celsius. Which once you convert it, you are 273. This now is equal now to 300 Kelvin. This is what I will have said. Now the volume was recorded 20 centimeter cubic at this temperature. Then calculate the new volume of the gas if it is heated to that one. Now, what will be the second volume? At temperature 2 at a temperature of 54 degrees Celsius. Now, you plus 273 to obtain Kelvin. Now, if that is the case, this is 7, then this is 12, then this is 3. Now, 327. Therefore, what will be the volume at this temperature? Therefore, from Charles' law, we know V1 over V2 is equal to T1 over T2. Therefore, remember we have to substitute what we've been given. The first volume is 20 over the second volume is the accent. Now is equal first temperature to 300 over, now this is second temperature 327. Therefore, you cross multiplication. You are having now the 300 V2 is equal now to 20 times 327. Then you divide by 300. Then you divide here by 300. Therefore, this comes out. Now the second volume will be equal now to 21.8. That is centimeter cubic. This is what we've been given. Now the volume. Now we conclude by saying volume, that is V2, will be equal now to 21.8 centimeter cubic at a temperature of 54 degrees Celsius. Now this is the volume that was supposed to be recorded at this temperature. As you may see, as you can see now here, the volume before it was 20 centimeter cubic. And now the volume after you have added the temperature means you have increased the temperature it is 21.8. Now there is an increase in volume, that is expansion, because there is a change in temperature. Now that's how we can talk about it, Charles law. So whenever you're talking about volume, the change in volume and temperature, relationship between volume and temperature at constant pressure, that is Charles law. And then you have to apply the Charles law so as you may find the value of what is missing. And this is the equation that is delivered from the Charles law mathematically. So this is the mathematical concept about Charles law. And using the mathematical concept about Charles law, it is where now you can find the volume which is missing. Even if now you've been asked to find out the temperature that is missing, remember, the temperature that will be obtained is in Kelvin. Then you have to convert that Kelvin into what? Degrees Celsius. By subtracting 273 from it. So this is all about Charles law and its application when solving the